Okay, so today we are going to continue talking about curvature. So last time we discussed the fact that if you take your RT to be some continuous curve, so let's say that this is your RT. So it's some curve in R3. So here's your axis, and here's your RT. Then the first thing we want to consider is the tangent vectors to this curve. That's going to be R prime of t and those are curves along vectors along this curve, which are tangent to the curve. And then we can discuss the, and then this leads to the unit tangent vectors, which we are going to call T of t. That's going to be equal to R prime of t divided by the magnitude of R prime of t. So we basically take our tangent vectors and we divide by their magnitudes. So that will give us something like this. So again, we have the same axis. We have the same curve, but now each one of these tangent vectors is going to be the unit vector. So this is T of t. Okay, and then we define curvature in the following way. We say that our curvature K of t, so curvature is defined at every point, at every time. So these curves are parameterized with time. And but the curvature is a number, and that's going to be the magnitude of the change of this t from here over ds, so small changes on your curve. And this is your curvature. And what this is telling us is as we move along our curve, so again, here's our curve. As we move along it, a small amount, a ds amount over here, how quickly are our unit tangent vectors changing? So for example, and again, the unit tangent vectors are these vectors here. In this case, they are changing. So we do have some curvature. And as we take small ds steps along the curve, we are going to get some positive number for curvature. So for example, if we have a line, so if R of t is a line. So let's say it's something like this. Here's our R of t. And here are our unit tangent vectors. Then we said that the magnitude of dt over ds, well, that's equal to 0. As you move along the line, your unit tangent vectors are not going to be changing. And so you don't have any curvature. So there are two formulas that are going to help us determine curvature, and we can use either one of them. The first one is going to be the magnitude of t prime of t, so the derivative of the unit tangent vector over the magnitude of r prime of t. So if you're given r of t, in order to find this, and I'm going to call this, let's say, formula 1. So if you're given your r prime of t, you need to find, your r of t, you need to find r prime of t, then divide by its magnitude, and that will give you t of t, which is r prime of t divided by the magnitude of r prime of t. And then you need to take the derivative of t of t. So then you take the derivative t prime of t. And in order to do this, well, the bottom part is just a constant. So this is going to be r prime double prime of t over the magnitude of r prime of t. And that goes, and then you take the magnitude of this, and that will be the top part of your formula for curvature. And we're going to see an example how to use this. The second formula, which is probably more useful, is the following. Second. Any questions so far? Okay, the second formula is going to be your curvature at some time t is the magnitude of r prime of t cross r double prime of t over the magnitude of r prime of t cubed. And we briefly discussed intuitively why this formula makes sense. If your r prime, so your r double prime of t is the acceleration, and your r prime of t is your velocity. And if your r prime of t and your r double prime of t are going in the same direction, then your cross product is 0. So let's do an example. If we had a line, and this is then your r prime of t, And then our r double prime of t will be going in the same direction. Your acceleration, it will even just be 0. Well, depending on how you move along the line, but it'll be going in the same direction. So these are, let's say, your r double prime of t. Then we have that r prime of t. So r prime of t cross r double prime of t is equal to 0. And so the magnitude of r prime of t cross r double prime of t is going to be equal to 0, which implies that we don't have curvature. Any questions? Okay, so let's do an example. So the first example, so they tell us that r of t is t, 3 sine of t, and 3 cosine of t. And we want to find the curvature. So using the first formula, we know that this is going to be the magnitude of t prime of t over the magnitude of r prime of t. So let's first try to find r prime of t. So r prime of t is equal to 1, 3 cosine of t, and -3 sine of t. That is our r prime of t. So then, in order to find t, so t t of t is r prime of t divided by the magnitude of r prime of t. And the magnitude over here, if you just take the square of these, same thing that we've seen before with cosine and sine, you're going to get 1 plus 9, and you're going to take the square root. So the magnitude of r prime of t is the square root of 10. So this is going to be 1 over the square root of 10, 3 cosine of t over the square root of 10, and -3 sine of t over the square root of 10. Any questions so far? So this tells us what t of t is. And then in order to find t prime of t, we just take the derivative again. So it's going to be 0, -3 sine of t over the square root of 10, and -3 cosine of t over the square root of 10. By the way, we can note that this is a helix. And so what we're trying to do is find the curvature of a helix. And this helix is going in the x direction. So it looks something like this. Okay. So now we found t prime of t. And so then in order to solve the problem, what we need is we need to have k of t, which is equal to the magnitude of t prime of t over the magnitude of r prime of t. So we already know the magnitude of r prime of t. It's the square root of 10. So the magnitude of r prime of t is equal to the square root of 10. So now the question is, what's the magnitude of t prime of t? So in order to solve this problem, we can just take the square root of 3 sine of t over the square root of 10 squared plus 3 cosine of t over the square root of 10 squared. And this gives us 3 squared times 1, so the square root of 3 squared times 1 over 10, which is going to be 3 over the square root of 10. Any questions?
Yeah, wait, how did you get the 3 on top?
So same exact trick. You take the sine and the cosine and you put them together and you take the 3 in front of them out. So sine squared plus cosine squared is 1, and then you multiply that whole thing by 3.
Oh,
Okay. And then you just add them normally. Okay, any other questions? Yeah.
Why would it not be 9? Does the 3 squared go away when you do the sine squared plus cosine squared?
So the 3 squared appears here. And then you have the square root. And so then you get 3 on top and the square root of 10 on the bottom. Any other question? Yep.
does this only work when the coefficients of sine t and cosine t are the same?
Yes. Yeah. But that's generally what they're going to ask. If not, then it would be almost impossible to actually solve this. Yeah.
What value did you plug in for t to get the magnitude of r
I'm
square root of that?
again, you have this cosine squared and sine squared. So that we already figured out. So you don't plug in a value. The question is, what is the magnitude of this vector over here? So if you take this and you square it, and you take this and you square it, and you take that and you square it, you take out the 3. So you have 9 plus 1, and you take the square root of that. That's the square root of 10. Yeah, does that make sense? Any other questions? Okay. So this type of trick of taking out the cosine and the sine does appear a lot, and I would just recommend that you see the pattern a couple of times and try to think about how to apply what we've been doing. So then, in order to find the curvature, you get the magnitude of t prime of t over the magnitude of r prime of t. And that is going to be 3 over the square root of 10 divided by the square root of 10. And this is going to be 3 over 10. So that's our curvature. And you will note that this curvature does not depend on time. And that makes sense because the helix is very symmetrical. So there isn't going to be a special point that will have different curvature than some other points. Same way circles have the same curvature everywhere. It's a very symmetrical type of problem. But anyway, the curvature of this helix over here is 3 divided by 10. Any questions about this? Okay. So another way of, so let's try another problem and just use the different formula. So if you have R of t is equal to t squared, 0, and t. And this time we're going to try to use the formula that the curvature is equal to the magnitude of r double prime of t cross r prime of t over the magnitude of r prime of t cubed. So the first thing that we need to do is we need to find r double prime of t and r prime of t. Okay, let me just write example 2 here. Okay, so r prime of t is going to be, and one way to see that it would be more beneficial to use the cross product formula here is that when you start taking the derivatives of this r of t, the t will disappear under the cross, the r double prime, and so, and you're going to get some constants. So r prime of t over here is going to be 2t, 0, and 1. That means that r double prime of t is going to be 2, 0, and 0. So now the question is, what is their cross product? So what is r double prime of t cross r prime of t? And that's going to be the determinant of the matrix I, J, K, 2, 0, 0, 2t, 0, 1. Give me 1 second. Let me just, okay, so this just changes a sign, but let's do it this way. So then here it's going to be r prime of t and um, 2t, 0, 1, 2, 0, 0. Okay, any questions so far? Okay, So this cross product is going to be equal to I times 0 minus J times, so T, 2T times 0 is 0, and then minus 2, so then just plus 2, plus K times 0, which gives you the vector 0, 2, 0. So what is the magnitude of this vector? Well, it's just going to be 2. So the magnitude of R prime of T cross R double prime of T is just equal to 2. And the question is, what is the magnitude? What is the magnitude of R prime of T cubed? Well, so first, what's the magnitude of R prime of T? So the magnitude of R prime of T is going to be, so R prime of T, 2T squared plus 1. So the square root of 2T squared plus 1. And so then we know our curvature. Our curvature is going to be two over the square root of 2T squared plus 1 to the third power. Any questions about this? Yes.
On the exam, we can leave it like that, we don't have to simplify it more.
Not, yeah. If it's like this, you don't have to simplify it. Any other questions? Yes.
So we can choose between the two formulas, but which one should we use?
So I would recommend that if you see that the vector is going to start having zeros when you take the derivatives, well, actually, they're both fairly similar in terms of how hard it will be. I would recommend to choose this formula in general, because like the other formula was useful when you had the sine and the cosine and you could take things out and it was easier to find the magnitude. But if you don't have that, it's just easier to do this. That would be my suggestion. Any other questions?
Can you just scroll down so that the answer?
Yes. So here's the answer.
Okay, thank you.
And now curvature does depend on T. So for different points on your curve, you're going to have different curvature. Okay, so that's actually all we need to know about curvature. In the book, there is another part of this section, but we are not going to need it for the exam or for homework, so we're not going to talk about it. And then the last part that will appear on the exam is motions in space. And we already started talking about this. Let me go to a different. So motions in space is all about acceleration and velocity. And so first, it's important to remember that if you have your curve R of t in R3, then your velocity V prime of t, sorry, V of t, which we call the velocity, is going to be v prime of t. And then a of t, which we call acceleration, is equal to a double prime of t, which is equal to v prime of t, is the acceleration. And if you've seen any physics, this should already be something that you know, and if not, then it is very important to understand why velocity is the derivative of r. And the reason it is because at any point on your curve, if you want to know how quickly you're going, you can ask what is the change as you vary time on your curve. So if here's your curve, the velocity would be at any point, it's a vector, and it tells you at that point how quickly, as you vary time, you move along this curve. And that's what velocity is. As you vary time, how quickly do you move along the curve? And acceleration is how quickly your velocity changes. It's the derivative with respect to velocity. And so that tells you if you vary the time, how quickly is your velocity changing? And that's acceleration. And it might be some other vector, maybe pointing inwards in this case, something like that. And that tells you how your velocity vectors are changing. Any questions about this?
Why is the acceleration point like in towards the?
Because this velocity vector in the next step will look like this.
Yeah.
And so the acceleration is kind of the difference between the first velocity vector and the second velocity vector. It tells you how that velocity vector changed, but you still put it at this point. So and if you know how acceleration feels, if like you're in a car and it turns, the acceleration, you feel the acceleration going in this direction.
Right. Okay.
And gravity also has a very similar type of feeling and math to acceleration, which is why the g constant is an accelerating constant. Any other questions? Okay. So the type of questions, there's only really one type of question that will appear on the test in regard to velocity and acceleration. And that is, let me try. That is, if you're given an object's acceleration, so you're told that the acceleration of this object is given in the form, and this is an example. So the acceleration of the object is given in the form 3t negative 4e to the negative t and 12 to the t squared. So that's your acceleration. And then you're told that at time zero, your velocity is 0, 1, and negative 3. And at time 1, time 0, your position is negative 5, 2, and negative 3. And now you're asked to find what is r of t, so the whole curve, the whole position curve, and v t. And the way you do this is fairly straightforward. You say that your velocity v of t is going to be, and you take the antiderivative of your acceleration, right? Because if we remember, we know that acceleration is equal to the derivative of the velocity, which is equal to the second derivative of position. So this means that you take your v of t and you say, okay, what is this? Let's take the antiderivative of each component. So that is going to be t squared over 3 divided by 2 plus some constant c1. Okay. And in the second component, we're going to have that your antiderivative is 4e to the negative t, right? If I take the derivative, the negative comes down, plus c2. And then in your third component, you're going to get 12 over 3, which is 4t cubed, plus c3. So this is your velocity at t, but we need to know what is c1, c2, and c3. We always need to add them because that's what happens when you take the antiderivative. And in order to do that, you just use your first initial condition. So that will be v at 0 is going to be equal to c1. And then from the 4e to the negative t, you're going to get 1 plus c2, and then you're going to get c3. And we know that that is equal to 0, 1, and negative 3. Okay, so that tells us that our C1 is equal to 0. Let me see if I wrote down.
What is the 4e to the negative e ends up being 1?
Oh, sorry, it ends up being 4. Yep, 4. Okay, so then our C2 is plus 4 is going to be 1. So our C2 is going to be negative 3. And our C3 is going to be negative 3. So our velocity then becomes v of t is equal to 3 over 2 t squared 4e to the negative t plus or minus 3 and 4t cubed minus 3. Any questions? Okay, and you can try to do the acceleration yourselves. That's take the antiderivative of the velocity to get the position vector. So for the last 10 minutes, I want to start going over some of the review problems, unless there are any questions about this. Okay, so the first problem tells us a projectile starts at this point and will be fired in a straight line in the direction k negative 2, 3. If we want the projectile to hit this target, then what should the value of k be? So first, whenever we see a problem with a line, we want to set up the equation of our line. So the points are the point is -3, 4, -6. So let's call this R0 is -3, 4, -6. Our vector V that forms the line is the vector K, -2 and 3. And the point that we're trying to hit, let's call it F0, is going to be 17, -6, and 9. So we set up the equation of the line, which is -3, 4, and -6 plus t times k -2, 3 is equal to the point that we're trying to get to 17, -6, and 9. So then from the first part of this, we get -3 plus tk is equal to 17. Which tells us that tk is equal to 20. Now we can use the second part. So let's use this, just the y coordinate, to figure out what t should be. So this will tell us that 4 plus so minus 2t is equal to -6. So that gives us -2t is equal to -10, where t is equal to 5. Now, once we know what t is, we go back to this equation and we get k is equal to 4. And that's the solution of this problem. Any questions about this? Yes?
Where do we find that paper?
It is in the files folder on Canvas. And there are answer keys, but. So the second problem says give a parameterization of the line which goes through the point 1, 2, 4, 2, 0, 5. And okay, so let's start with that. So our P1 is the point 1, 4, 2. And our P2 is the point 2, 0, 5. So our vector V between them, so the vector from P1 to P2 is going to be 2 minus 1, which is 1, 0 minus 4, which is -4, and 5 minus 2, which is 3. And so then our line R of t is going to be 1, 4, 2 plus t 1, -4, 3. Okay, and then the second part of the question asks if point A is where the line intersects the XY plane and point B is where the line intersects the YZ plane, find the distance between A and B. So the way to do this is to try to get the formulas of the planes that are being discussed. So one of the planes that we are told is the XY plane. And that's going to just have the equation, right? So its normal vector is just this, a vector pointing in the z direction, and it goes through the origin. So we can say that the equation of this plane is z is equal to 0. And the second plane is the one going through the yz coordinate, so yz, and that's just going to be the plane x is equal to 0. And now we can imagine this line going from here to here, and we're asked, okay, there's a point where it intersects this plane, there's a point where it intersects that plane, this is A, this is B. What is the distance between these 2 points? Okay, so we need to first find where these intersections happen. And the first equation tells us that, so plugging this into here, where does it intersect the xy plane? That happens when 2 plus 3t is equal to 0. Or in other words, t is equal to negative 2 over 3. And let's call this T1. So that's when you intersect the XY plane. The second part is where it intersects the YZ plane. So that's using this equation. And so then we plug in the X part of this. So we get 1 plus T is equal to 0, which tells us T is equal to negative 1. And let's call this T2. So at T2, it's negative 1, and at T1, it is 2 over 3. So now we just need to find the points A and B. So let's say A is for the T1 point. So A is going to be equal, and then you just plug in, well, it's easier to do the T2 point, so let's just plug that in. It's going to be the point 1 minus 1, which is 0. 4 minus 4, which is going to be 8. And finally, 2 minus 3, which is negative 1. So that's how you find the point A. You can then find the point B by plugging in the T1 into your R2, and then just find the distance between these 2 points, and that will solve the question. So try to finish this question, see that you get the right answer. Yes?
Is it point A of the XY plane?
So I don't know which one is what, but okay, so this will be the point B. Is that what you mean? Whatever it is, I'm not sure. If you have questions, I'm asking. Yep. Yeah.